Hello everyone, welcome back to another episode of Solving LEETCODE Hard Question. Today's question is the skyline problem. The question is as follows. A city skyline is the outer contour of the silhouette formed by all the buildings in that city when viewed from a distance. Given the location and heights of all the buildings, return the skyline formed by these buildings collectively. The geometric information of each building is given in an array buildings, where each element has 3 fields, left, right, and height. The skyline should be represented as a list of key points sorted by their x-coordinate in the form of x1, y1, x2, y2, etc. Each key point is the left endpoint of some horizontal segment in the skyline, except the last point in the list, which always has a y-coordinate 0 and is used to mark the skyline's termination, where the rightmost building ends. Let's look at the following example. In this drawing, we see 5 buildings overlapping each other, and the output of the skyline are the following coordinates. As mentioned before, they are the start of the horizontal segments, sitting at 210, 315, 712, 120, 1510, 28, and 240. How do we solve this? Pause here if you like to think independently for a moment. To get to the bottom of this problem, what we really need is to keep track of a list of the current buildings as we traverse through the x-coordinates, and we also need to keep track of the largest height, because that will give us the skyline contour. Because we're keeping track of the largest element in a data structure, max heap is useful here. There are 3 things we need to do to maintain the list of current buildings. We need to add to the buildings whenever we see a new left edge. So that is to simply add it to the max heap. Whenever we encounter a right edge, we need to remove them from the current buildings list. Lastly, when the top of the heap changes, that means the skyline contour has changed, so we need to add to our result list. Let me elaborate more on the next slide. As mentioned before, we'll check the left and right edge starting from the leftmost x-coordinates. So this means we need to combine both the left and right edges into a new data structure, sort by the x-coordinates, and then we're ready to build our heap. In each heap element, we need to store the height. Since Python by default will maintain a min heap, we'll store the negative of the height to achieve a max heap feature. In addition, we also need to store the right edge, and this is helpful for us to know when to pop from the heap. So to add to the building, we push negative height and right to the heap, and to remove from the building, we pop. Note that this will only pop the top element from the heap, but that is okay, because only the top element will affect our skyline result. As long as the expired building is not in the top element, we can delay its popping. But how do we know it's an expired building? That's when we need to check the right index. If the current element's right index is greater than the top heap element's right index, that means the top heap element is an expired building, so that's when we pop it. And lastly, to modify the skyline result, when we see a different height than the last tracked height, then we append to the skyline list. Putting everything together, this is the Python code. We first combine the left and right edges to build a new list, and then sort them by the x-coordinates. Note that I also added a secondary sort index by decreasing height. This is because if we see 2 elements with the same coordinates and different height, we want the skyline to only capture the tallest element. So just walking through the rest of the code, for each element, we first clean up the expired buildings, in other words, the old buildings. Then we insert the new building and determine if a new skyline is formed. The final time complexity is O of n log n because of the sorting, and the space complexity is O of n for the max heap. That's it for today. Let me know if you have any questions, and see you next time.